Hello everyone, I'm Harshita and this is Group 9 presenting you the final project presentation on virtual network routing implementation. These are today's agenda for the presentation. So let's get started. This project provides an overview of virtual network routing implementation for forwarding messages using the distance vector routing protocol from source node to the destination node. The distance vector routing protocol in computer networking is a protocol that is used to select the best path from the source to the destination based on the number of hops that the packet needs to traverse. Distance vector routing protocol uses the Bellman-Ford algorithm for best path selection. A virtual network can be considered as a network in which all connected devices like servers, data centers, and virtual machines use software to communicate with each other. This, among the other things, permits the network's range to be extended to its maximum effectiveness. When configuring a virtual network, a system shares the traffic with an external host in the same way that a system without any virtual network would. Traffic flows from the zone to the virtual switch through a virtual network interface card and finally to the physical interface which sends information to the network. The background of this project goes like a virtual network is a communication network that mimics a real network by pooling hardware and software network capabilities into one unit. Virtual network can improve network scalability, improve digital security, and lower expenses for business. The main aim of this project is to communicate using distance vector routing protocol across the network. We aim to create a virtual network routing among virtual nodes to enable communication between them. For this, distance vector routing protocol will be used to select the best path possible for sending the messages. In this routing protocol, when the routing packet is received by a router, it saves the recently received distance vector from its neighbors. It recalculates the distance when it finds that a neighboring link is cut off. So this calculation is done to reduce the cost to each destination. So as you can see on the screen, this is the equation for the Bellman-Ford algorithm where the distance is calculated, where here the D stands for the distance and the C is the cost, X and Y are the neighbors. Moving on to the design and architecture. In this project, we are building a network that consists of 9 nodes, and these nodes are built using the TCL language. We are simulating this project in Network Simulator 3, that is NS3. We are assigning various bandwidths between the nodes, which will be used by distance vector routing protocol to select the best path to forward the message to the destination. In our network, we are setting node 0 as a source node and node 8 as a destination node to check the message flow. There are two routes to reach node 8 from node 0. Purposely, we have assigned the upper route as high bandwidth and the lower route or lower bandwidth. Hence, the message starts flowing from source to the destination. It automatically selects the upper route even though both the routes have the same number of hops. To check if the distance vector routing protocol is working or not, we are shutting down one link. That is, we are shutting down the link in node 3 and node 5. Now the message has to pass through a different route, and this is done by using distance vector routing protocol, which selects the second best path to reach the destination. The network consists of 9 nodes connected through links. Distance vector routing protocol is to be implemented for routing purposes. We are sending FTP traffic from selected source node to a destination node. The distance vector routing protocol is implemented to select the best route between source and destination. NS3 is used for simulating a topology using the tool command language and namtrace function. Now, I'll hand it over to Sandesh for the demonstration of the project.
Thank you, Harshita, and hello everyone. Let's dive into the demo now. First, I will explain the code that we have written in TCL language to create a network topology, and then I will show the demo of our project. This is the code that we have written. This is the end function we have written, which we will call in the end to stop the network simulation process. Here we are creating the nodes in our network. As you can see, we have created 9 nodes starting from N0 to N8. Below, we are setting up the duplex links between all the nodes that we have created above. As you can see, we have assigned the bandwidth to all the links. As explained earlier in the system design and architecture section, we are assigning high bandwidth to upper route, which is 20 MB, and low bandwidth to the bottom route, which is 5 MB. To test the distance vector routing protocol to see which route the protocol is selecting. Now we are setting up the TCP connection because we are going to send FTP packets from the source and destination, and FTP is TCP protocol. Here we are setting the N0 as a source node and N8 as a destination node. Below we are setting the FTP over TCP connection. As you can see here, we are starting the packet flow at 0.1 second, and at 0.5 second we are shutting down the link between N3 and node N5 to check if our distance vector routing protocol is selecting the new route or not. After 2 seconds, the link between N3 and N5 is coming up, and at 3 we are stopping the traffic flow, and we are terminating the simulation at 3.5 seconds by calling the end function that we have written in the beginning. Now we will see the demo of our project. Here I am running the project.tcl file to start the simulation. As you can see, the simulation has been started, and the traffic will start flowing at 0.1 second, which we have defined in our code. As you can see, the traffic has started flowing from N0 to N8, and the upper route is selected by default by distance vector routing protocol. Now the link between node 3 and node 5 is down, so the traffic will start flowing from the bottom route. Here there are two routes available. First is N0, N1, N3, N4, N6, N7, N8, and the second is N0, N2, N4, N6, N7, N8. Distance vector routing protocol has selected the second route because it uses Bellman-Ford algorithm, which is the shortest path selection algorithm. Here the first route has 7 hops and second route has 6 hops. That is why the second route is selected over first, which proves that our distance vector routing protocol is working perfectly. And the conclusion is, with this project, we have implemented a virtual network routing using the Network Simulator 3 and TCL programming language. And we have used distance vector routing protocol in order to send messages across the network. We have successfully sent the packets from source to destination using the distance vector routing protocol. We have presented the details including the network design, its implementation, and the results. These are the references that we have used for this presentation. Thank you so much for listening to our presentation.